All right, first one. Okay, so we're going to solve this one, example 1. Square root of 2x minus 1 equals square root of x plus 4. Okay. Okay, did anybody notice what's different about this one than the ones we did yesterday? How is this one different from the ones from yesterday? How many square roots are there? There's 2, right? Okay, so we can have multiple square roots, but here's the thing. They have to live on opposite sides of the equal sign, okay? So square roots must be separate. Square roots must be separate. So it's okay if you have multiple square roots. They're like 2 siblings who are arguing. They need to be in their separate rooms and separate sides of the equal sign, okay? All right, so we got that. So we can proceed to step 2. Step 2 is square both sides, okay? So grab the left side, squared. Grab the right side, squared. And the cool thing about having multiple square roots is whenever you square a square root, all you're doing is just unlocking the stuff underneath. That's it. So now I just have 2x minus 1 equals x plus 4. Pretty easy, right? Okay, so then you just go, is that linear or quadratic? We have only x's, it's linear, so we want to get x by itself. So I can move one of these x terms. I'll just subtract this 1x, put it over here. 2x minus an x is just 1x. Bless you. And then you just add 1. So x is 5. Right? Maybe. Maybe x is 5. Right? We have to check. That last step, the check step. Okay, now we can check many different ways. Right? We can plug this in. We can check in a table. We can check. I would not check in a table. That would not be easy to do on this one. We could check with a graph. This one's actually easy just to plug in. I'm just going to plug in my answer. So every time I see an x, I'm going to plug in the number 5. So is the square root of 2 times 5 minus 1 equal to the square root of 5 plus 4? So I'm plugging in 5 twice because there's 2 different x's. So 2 times 5 is 10. 5 plus 4 is 9. So is the square root of 10 minus 1 equal to the square root of 9? Yeah. They're the same. I could go further and say that they're 3. Okay? So that means that 5 is not extraneous. It is a solution. So it gets to go in the solution set. Okay? That's actually not bad. Okay, let's look at one that's a little bit different. Similar but different. Example 2. Square root of 7x plus 2 equals 3 times the square root of 3x minus 2. Okay, so here's another one where we have 2 different square roots, and they are separated, right? They're on opposite sides of the equal sign, but the one on the right has a 3 in front of it. That 3 is being multiplied. So if we try to do this step where we isolate the square root, well, this one is isolated, but this one's not. It's got a 3 times. So you might think, okay, we'll just divide by 3, right? Well, if I divide by 3, that gets rid of this one, but then it puts a 1/3 in front of this one. So then you think, okay, we'll multiply by 3. Well, then it just goes back here. So we would just be playing ping pong with this 3, back and forth, back and forth. Okay? So as long as one of your square roots is isolated, this one is, you can square both sides. Okay? We just have to be a little careful with what we do with the one on the right. But we can square both sides. The one on the left, we're just going to cancel out the square root, leaving us with x plus 2 equals. Now on this side, we're squaring the 3 and we're squaring the square root. Okay, so 3 squared is 9. And then when we square the square root, all we're doing is canceling out that square root. But what operation is going on right here? Multiplication. So when we drop the square root, we still have to make sure we have multiplication happening. Okay? Is everyone okay with how we got here? Now from here, it's just like the other problem, right? Now it's linear. There's no x squared. So we just do all of our basic algebra skills. We're going to distribute that 9. 9 times 3x is 27x. 9 times negative 2 is minus 18. Okay, we want x's on one side, so just pick one of these to get rid of. I'll get rid of the 7x on the left, so we'll subtract it. Yep, 20x. So we have 2 equals 20x minus 18. And then add 18. Two plus 18 is 20. 20 equals 20x. And then divide by 20. (20) divided by 20 is 1. And we have to say, well, maybe, right? So we have to check it. Don't forget we got to check it. So I checked the last one by plugging in. I'm going to check this one by graphing it. Okay? So if you're going to check with a graph, by the way, there's no rhyme or reason. I'm just picking a way to check. Okay? To check with a graph, what you do is you make a function out of the left side of your equation. So y equals 7x plus 2. And then I make a function out of the right side of my equation. So y equals 3 square root of 3x minus 2. So now that they're both functions, I can graph them. Y equals square root 7x plus 2. Y equals 3 square root 3x minus 2. And where they intersect, my x value should be 1. And I find where they intersect, that x value is 1, so it checks out. We are correct. So it gets to go in the solution set. Okay? All right, so if you ever have a problem where you have 2 square roots, it's either going to look like example 1, where they just cancel each other out, or it's going to look like example 2. All right, those are the only, if you see 2 square roots, that's how they're going to go. Okay? All right, now we get to look at the ones where we get extraneous solutions. So, all right, I'm going to tape this little notice here in my notebook. And we have had extraneous solutions before when we did absolute value. Okay? All right, but let's look at this. This is the example 3, and this one is square root of x plus 7 minus 5 on the outside equals x. All right. Okay, so we have one square root in the problem, but it is not isolated, right? There's this minus 5, and we don't want that on the same side because we want this isolated. So first thing we're going to do is add 5. So we're looking at the square root of x plus 7 equals x plus 5. All right, now our square root is isolated, so we can go to the next step where we square both sides. So square, and over here we square. Okay, so on the left side, our square roots just cancel out, right? So we're left with x plus 7. But on the right side, there's no square root, so nothing cancels out. And we can't just distribute the squared because what we're squaring is x plus 5. So think back to last semester. We did a lot of work with these, they're called perfect square trinomials. X plus 5 squared means x plus 5 times x plus 5, right? That's what x plus 5 squared means. And then you got to remember, okay, well, how did we multiply that? To multiply something like this, you either do FOIL. So we either multiply that with FOIL or with the box method. Remember this? And you pick whichever one you're more comfortable with. I remember we were comfortable with the box. So I'm going to go down. And this is kind of like aside from our work. I'm just going to go under this little thing and draw a little box to do box multiplication. So x plus 5 along the side and x plus 5 along the top. Remember this? Punnett square. We multiply to fill in the boxes. So x times x is x squared. X times 5 is 5x. 5 times x, 5x, and 5 times 5, 25. Then, to get the answer to this, you add up everything in the box. So x squared, and then these are like terms, right? 5x and 5x are the same term. So that makes 10x plus 25. Okay, now I can come back here and write that as the answer to x plus 5 times x plus 5. Okay, now in our notes from the other day, on our little note page, where is that? After we square both sides, we're either going to be left with something that's quadratic or linear. Quadratic has an x squared in it. And to solve those, we set it equal to 0. Ours is quadratic. Okay? And I know that because there's an x squared in my equation. So the way we solve quadratics is we get everything on the same side of the equal sign as the x squared. So everything on the other side we're going to have to remove. So this positive x, we subtract it. And we subtract it from the other side. And that plus 7, we subtract it. Subtract it from this side. So now we have 0 equals x squared, 10x minus an x. 10 apples minus an apple is 9 apples, right? So plus 9x. And 25 minus 7 is 18. Okay, now, once it equals 0, you solve it. And we have a lot of ways to solve quadratics, right? Like we had like 2 months where that's all we did. But I will tell you for this unit, I'm not going to give you ones that are not able to be factored, okay? They're all going to be able to factor nice and easily. We're not going to have to pull out quadratic formula, okay? So this is basic factoring. Factors of 18 that add up to 9. So 9 times 2 is 18. Is 9 plus 2 equal to 9? No. 6 times 3 makes 18. Is 6 plus 3 equal to 9? Yes. So these are the numbers that we use in our factors. So x plus 6 times x plus 3. Okay, now remember, these are the factors. They are not the answers. To get the answers, we would have to set each of these equal to 0. So I would set x plus 6 equals 0, or the other one, x plus 3 equals 0. So x would equal negative 6, or x would equal negative 3. Okay, now, that's great. We have answers, but now we have to check. Super important to check, okay? You know what? Let me just plug in. I'm going to plug this in, so we got to make sure we check these. I'm going to plug each of these in. So I'm going to try x equals negative 3 first. So square root of, now I'm going to go back to my original equation and plug in negative 3. So square root of negative 3 plus 7 minus 5, does that equal negative 3? So because I have two x's, I need to plug in negative 3 twice. Negative 3 plus 7 is 4. The square root of 4 is 2. So is this true? Is 2 minus 5 equal to negative 3? Yes, it is. So x equals negative 3 is a good answer. Now let's try negative 6. Plugging it in for x. So square root of negative 6 plus 7 minus 5, does that equal negative 6? Well, negative 6 plus 7 is 1. The square root of 1 is 1. So is 1 minus 5 equal to negative 6? 1 minus 5 is negative 4. So this doesn't work, right? Okay, now that can happen. Sometimes that can happen, okay? So when that happens, this answer of negative 6 is extraneous. And this little yellow paper here reminds us of what an extraneous solution is. It's a solution that we get from doing all the right math, but it's not a solution. That's why we have solution sets. You might be wondering, like, who cares about solution sets? Well, this is exactly why. Because x equals both of these numbers, but only negative 3 is invited to the solution set, because negative 6 was extraneous. Okay? Now, are you always going to get an extraneous solution? No. You could have two good answers. Or you could have two answers and both of them are extraneous. The only way you know is by checking. Okay? Now, on the last example, I'll check a different way. This I checked by plugging in. I'll check a different way on the next one. Okay? All right. This one I'm going to kind of break it apart and let you try parts of it. Okay, so our last example, example 4. Here we go. We're going to do the square root of negative 3x minus 5 equals x plus 3. Okay, so we have a square root, and it's by itself. So as long as your square root is by itself, you go to square both sides. And grab this and square it. Okay? So then you have the square root. Oh, no, not the square root. The square root canceled out. We just have negative 3x minus 5 equals x plus 3 squared is x plus 3 times x plus 3. Okay, now you take a minute and figure out what that is going to be. Write your next step. Okay, I'll set it up for you if you need the box. That's how we multiply that out. Okay, so you take a minute and try that step on your own. Okay, we get x squared plus 6x plus 9. Okay, that's quadratic, so we need it equal to 0, right? Quadratic means everything goes on the same side as the x squared, so these things need to go. Opposite of a minus 3x will be a plus 3x. Opposite of minus 5, that'll be plus 5. So we have 0 equals x squared plus 6 plus 3 is 9, so 9x plus 9 plus 5. Oh, 14. I'm like blanking out. What is 9 plus 5? It's 14. Okay, can you take it from there? Can you write the factors? So something times something, and then try to get the two answers. So think factors of positive 14 that add up to a positive 9. That's what you're trying to think about. Okay, factors of 14 that add to 9 are 7 and 2, right? So we have x plus 7 and x plus 2. And if you can hop right to the solutions, if you remember, oh, the solutions are just the opposite sign of the factor. So x is negative 7 or x is negative 2. Maybe, right? We have to say maybe because one of those, or both of those, might be extraneous. So I'm going to check this one with a graph, because this one's graph is interesting. Okay, so I'm going to make a function out of the left side. Equals square root negative 3x minus 5. And a function out of the right side, y equals x plus 3. Okay, so when I look at these, this is what it looks like. And I see they only meet once, but I got 2 answers. So let's figure out which one it is. Okay, when x is negative 2, that is the only answer, so negative 7 must be extraneous. So the only number that gets to go in the solution set is negative 2. Okay, now how could I know? Is there a way that you can know that without necessarily grabbing Desmos? Yes. There's a way you can find out that negative 7 is extraneous. Square roots can never equal what kind of numbers? Negative, right? So if you plug in negative 7, who cares what this is, right? This is a square root. I just know that what this is, it cannot equal something negative. So if x is negative 7, what's negative 7 plus 3? Negative 4, right? So that's not right, because that would make this equal a negative. Now if x is negative 2, what's negative 2 plus 3? Well, that's positive 1. So that one will work. This one won't. And fun fact, where does this even come from? Like, how does that even make sense on the graph? Well, what if, instead of this being the positive square root, what if the question said the negative square root? Guess what the answer is if we took the negative square root instead? Oh, there's negative 7. That's why we're getting all these, because when I make a quadratic, the quadratic has 2 sides, right? Parabola's got 2 sides, but a square root doesn't. Okay? So, but you got to check, because sometimes they'll both work.